Good morning, or afternoon, or evening, whenever you're working on this section. We only have one section in Chapter 9 that we will be covering, which is 9.3, which covers equations and inequalities involving absolute value. We are using the Blitzer Introductory and Intermediate Algebra text, and I am Professor Shannon Gracie from Maricosta College. So here we go. We'll be looking at how to solve absolute value equations, how to solve absolute value inequalities in two formats, less than and greater than format, and talking about absolute value inequalities with no solution or infinitely many solutions, and then solving applications using these skills. So warming up, in introductory algebra, you would have covered, I think in chapter 2, I believe it's section 2.7. So if you need a little bit of practice on inequalities, if you go back to the 2.7 video from Blitzer, that should get you caught up. And that might be a good idea. A lot of times people have some trouble with that initially, and going back over that will be beneficial. So let's warm up by graphing the solution of this inequality. Go ahead and pause the movie and do your thing. Okay, so here we go. We want to graph all numbers between -6 and 6. That is the solution for this inequality. We do not include -6 or 6 because there's not a line under the inequalities. So the way you graph this is you put a parenthesis around the endpoint, and then you shade the numbers in between to show that any number between -6 and 6 will make this a true statement. Now, interval notation, they didn't ask for this, so don't worry if you didn't put it down, but interval notation, the solution would be from -6 to 6. So these are the answers for this problem. Okay, so that the graph is the picture, and the interval notation says all values between -6 and 6, non-inclusive. All right, so here we go. How would one rewrite an absolute value equation without absolute value bars? So if C is a positive real number and U represents any algebraic expression, then absolute U equal to C is equivalent to U equal to C or U equal to the opposite of C, or -C. So if you take a look at the absolute value of x equal to 6, if you recall, absolute value represents the distance from 0 on the number line. So what this equation is actually saying is which number or numbers are 6 units away from 0 on the number line. So here we go. If you look, and if we were to actually graph this, you don't usually graph them in this form, but do you see that 1, 2, 3, 4, 5, 6, you could actually plot that number, right? That single value. That's 6 units away. And then 1, 2, 3, 4, 5, 6, -6 is 6 units away. So when you're solving these, you would say, oh, well, x would equal to 6, or x would equal to -6. So the u in this statement is x, and the c in this statement is 6. So in roster notation, this one would go in roster notation because there's only 2 values, so we can just list the values. And so there we go again. We have the picture, and we have the solution. All right, so next up, we have something just a wee bit more complicated. The absolute value of x minus 3 equal to 6. So with absolute value equations, you always want to make sure you have the absolute value alone on one side and everything else on the other side. So we have that situation here, all right? Now let's take a look at this one. We still want to be 6 units away on the number line, but now it's 6 units away from this quantity x minus 3. So if you think about it, this quantity inside, this is our u, x minus 3 has to be equal to 6, or x minus 3 has to be equal to negative 6. So if you solve this, it ends up with two very simple linear equations in one variable. So if you add 3 to both sides on this first equation, you get x is equal to 9. And over here, if we add 3 to both sides, we get x is equal to negative 3. So now, it's always kind of a good idea to check your solutions. So you check it in the original equation. So if we're checking x equal to 9, we would have absolute 9 minus 3, is that equal to 6? Well, absolute 6, is that equal to 6? Yes, because the absolute value of 6 has a result of 6, and 6 does indeed equal to 6. And then similarly, if you're checking x equal to negative 3, we would have absolute negative 3 minus 3, is that equal to 6? Absolute negative 6, is that equal to 6? 6 equals 6. So we're done. They both check out. Once you know they both check out, you can go ahead and put your answer in roster notation. And the two answers were negative 3 and 9. Now, if we wanted to look at what a picture would look like, we would have negative 3 here and 9 here. So notice, and I won't have you graph those most of the time. This was just sort of an exploratory exercise here, but I want you to see the difference. We found two distinct values for x instead of an interval of values for x. And that's the difference between absolute value equations and inequalities. All right, so here we go. Example 1, I've got 4 examples here. Why don't you go ahead and try A on your own. You don't need to graph it. You can just solve it and then check your solution. So pause the movie and give A a try. Okay, let's see how you did. Our u in this case is 5x plus 7. So 5x plus 7 is equal to 12, or 5x plus 7 is equal to the opposite of 12. So solving this equation, we would get 5x is equal to 5 when I subtract 7 from both sides, and then x would equal to 1, or 5x when I subtract 7 from both sides will be negative 19. So dividing both sides by 5, I would get x is negative 19/5. Now let's go ahead and check our solution. I'll do that in a different color. So we'll check x equals 1 first, and that would be absolute 5 times 1 plus 7, is that equal to 12? Well, 5 times 1 is 5. 5 plus 7 is 12. So absolute value of 12, is that equal to 12? 12 is 12. So that guy checks out. And then for x equal to negative 19 fifths, we have 5, absolute 5 times negative 19 fifths plus 7, is that equal to 12? These 5's divide out to be 1, so we would get negative 19 plus 7 is negative 12 inside the absolute value. Is that equal to 12? 12 does indeed equal to 12, so it checks out. So therefore, our solution will be negative 19 fifths and 1. Now notice I'm solving this using the algebraic processes and rules for absolute value equations. I am not plugging in random numbers and checking. So checking at the end is okay to make sure your answers worked out, but I want you to follow these processes. I don't give any partial credit for guess and check. Okay, so here we go. Let's do part B together. Part B, we have an absolute value, but it's being multiplied by 7. So we first need to get the absolute value alone. So you can either multiply by 1/7, which is equivalent to dividing by 7. So 1/7 times 7 is 1. So we'll end up with absolute negative x plus 11 is equal to 3. And now we can apply the rules for absolute value. Negative x plus 11 is 3, or negative x plus 11 is, good, the opposite of 3. So negative x would equal to negative 8. X would be 8. Or negative x would equal to positive 8, and x would be negative 8. Oh, my bad. Negative x plus 11 would be equal to negative 3. When we subtract 11 from both sides, we would get negative x is negative 14, and multiplying both sides by negative 1 gives us x is 14. So now, come over here and we do our check. So for x equal to 8, we have 7 times absolute value of negative 8 plus 11. Is that equal to 21? 7 times absolute value of 3. Is that equal to 21? 7 times 3. Is that equal to 21? 21 equals 21. It checks out. Then for x equal to 14, we would have 7 times absolute, negative 14 plus 11. Is that equal to 21? 7 times absolute of negative 3. Is that equal to 21? 7 times 3. Is that equal to 21? 21 equals 21, and it checks out. So we get two results that work. We get 8 and 14. All right. So moving right along, we have another situation where our absolute value is not isolated. So we have to first add 8 to both sides, and we will get the absolute value of x minus 4 equals 17. And applying our rule, we get x minus 4 is 17, or x minus 4 is negative 17. So x would be 21, or x would be negative 13. And checking our result. X equal to 21. We would have absolute 21 minus 4. Is that equal? Oh, sorry, we got to use the original. Absolute 21 minus 4 minus 8. Is that equal to 9? So we'd get absolute 17 minus 8. Is that equal to 9? 17 minus 8. And 9 is indeed 9. So that one checks out. And x equal to negative 13. We have absolute of negative 13 minus 4 minus 8. Is that equal to 9? Absolute negative 17 minus 8. Is that equal to 9? 17 minus 8. Is that equal to 9? 9 equals 9, and you're good. And again, you can use your calculator to check. Since we have time in the video, I figured I would show the checks. So our results were negative 13 and 21. Okay. So last up, again, we have a situation where the absolute value is not isolated. So we first need to isolate absolute value of x, and we end up with negative 1. Be careful, you want to use your number sense here. This guy is an extraneous result, okay? Remember, the absolute value is the distance from 0. Distance is not negative. So if you get an absolute value that's isolated on one side and a negative number on the other side, you end up with no solution. So you remember, you put either the empty set brackets or you put the empty set. If you had gone through and solved this equation, what would have happened is during the check, you would have gotten answers that didn't work. So here we go, moving along. Now we move on to the case where there's an absolute value on each side. Right? So if you have absolute u equals absolute v, you just pick one side to designate as the absolute value. So you can say u is equal to v, or u is equal to negative v. So here we go. This one, using the definition, if u is 2x minus 7 and v is the x minus 12, we would say 2x minus 7 is equal to x minus 12, or 2x minus 7 is equal to the opposite, or the negative of, x minus 12. And you got to put parentheses around it. So solving, you see, if we were to subtract an x from both sides and add 7 to both sides, we would get 1x is equal to negative 5. And over here, we need to work through the right side a little bit. Distributing the minus, we get negative x plus 12. And now if we were to add x to both sides and add 7 to both sides, we would have 3x is equal to 19. And now, isolating the x, we would get 19/3. So again, checking our results. So for x equal to -5, we have absolute 2 times -5 minus 7. Is that equal to absolute -5 minus 12? So simplifying inside the parentheses, 2 times -5 is -10, minus 7 is -17. So we get absolute -17. Is that equal to absolute -17? Well, 17 equals 17, so that checks out. Now for x equal to 19/3, that'll be a little bit more computation. Remember, you can use your calculator for the check. So absolute 2 times 19/3 minus 7, is that equal to 19/3 minus 12 in the absolute value? So here we'll end up with, if we get a common denominator, we would have 38/3 minus 21 all over 3. Is that equal to, again, common denominator, we would have 19 minus 36 all over 3. So 38 minus 27 gives us 17/3, or 38 minus 21 rather is 17. It's all over 3 in the absolute value. And then 19 minus 36 is -17, and then that's over 3. So 17/3 does indeed equal to 17/3. So that one checks out. So our result will be, our results will be -5 and 19/3. All right. Now we move on to absolute value inequalities. So here we go. If C is a positive number and U represents any algebraic expression, then absolute U less than C is equivalent to -C less than U less than C. So that is the rule for that one. Now, the rule is also valid if you replace the less than with the less than or equal to. So let's come back to, remember how we had done our warm-up problem? So think about it. For the absolute value of x to be less than 6, you've got to have numbers, on the positive side, numbers that are less than 6. That part's easier. So if you think about it, you'd go here, right? So you can think of it 0 to 6. Wouldn't they all work? I mean, any of these numbers that you plugged in would be less than 6. Now looking at the negative side, if we tried -1 for x, the absolute value of -1 is +1, so that works. In fact, everything works, do you see, until you get beyond, at or beyond -6. Just try -7. Absolute -7 is +7, which is greater than 6. So what ends up happening most of the time with a less than absolute value inequality is that you'll get a segment a segment of the line. When we start going to greater than absolute value inequalities, what you'll see is you'll usually end up with the tails of a line. So this is just a part of a line, a segment of a line. So here, using our definition, we would have said, oh, well, x was in the absolute value. It will be between -6 and 6. So in interval notation, the result is -6 to 6, and this is our answer to this problem. So let's do part B together. What we need to do is we need to isolate the absolute value. So if we were to subtract 8 from both sides, we would have -3 times absolute 2x plus 7 is greater than or equal to -9. Now recall that when you multiply or divide by a negative number in an absolute value in it, or when you multiply or divide by a negative number in an inequality, you flip the inequality. So here we need to divide both sides by -3 to isolate the absolute value. So we'll get absolute 2x plus 7 is less than or equal to 3 because of dividing by the negative. So now we can apply the rule. The rule is you've got 2x plus 7. That's going to be in between -3 and 3 because we've got it into the format to apply the definition. And working on this further, we subtract 7 from each portion of the inequality, and we'll get -10 is less than or equal to 2x's is less than or equal to -4. We didn't need to switch anything because we were subtracting, not multiplying or dividing by a negative. Now, if we divide each component by +2, we will have -5 is less than or equal to x is less than or equal to -2. So when you are including your endpoints, like we are here, right, we will have a square bracket, and we include all the numbers in between. And then the interval notation looks like just the same. So these are the answers for this problem. Okay, so now we learn about the other end, solving absolute value inequalities in the form of absolute value of u greater than c. So if c is a positive real number and u represents any algebraic expression, then absolute u greater than c is equivalent to u is less than -c or u is greater than c. So this is the situation where we're going to get the tails of the line for most of the problems. So the rule is it is also valid if the greater than is replaced by a greater than or equal to, which is what that little line underneath means. So here we go. Just trying some numbers. If I plug in 0 for x, is that true? Good. No, because absolute value of 0 is 0, and 0 is not greater than 6. So again, on the positive side, it's easier to see. Numbers that are to the right of 6 will satisfy this inequality. We're not including 6 because it's a greater than, not a greater than or equal to. Now let's look at the other end. If I plugged in -10, Well, the absolute value of negative 10 is positive 10, which is indeed greater than 6. So that's why you've got this less than the negative of that value, because all of these values, once you apply the absolute value to them, they also work. So you end up with the tails of the graph. Now the way to put this answer in interval notation is you have minus infinity to minus 6 union. So this means or positive 6 to infinity. There's a gap in between them, so you can't just do 1. So applying the definition, we would have gotten x is less than negative 6 or x is greater than 6. But I wanted to show you why that was true. So this is the answer to this problem. Okay, so next up we've got one that's a little bit more complicated. So first of all, we are going to need to add 10 to both sides in order to start isolating the absolute value. This will give us 5 times the absolute value of 12x minus 1 is greater than or equal to 12. And then dividing both sides by positive 5, we will have absolute 12x minus 1 is greater than or equal to 12/5. So now we can apply the definition. We will get 12x minus 1 is less than negative 12/5, or 12x minus 1 is greater than positive 12/5. So when we add 1 to both sides, remember you have to get a common denominator for the right side. So we will end up with 12x is less than negative 12/5 plus 5/5 is negative 7/5. And then if we multiply both sides by 1/12 to get x alone, we will have x is less than negative 7/60. Working on this side, if we add 1 to both sides, we will need to also get a common denominator. 5/5 gives us a common denominator. So we'll get 12x on the left side, and that's greater than 12 plus 5 is 17/5. And then multiplying both sides by 1/12 to isolate the x, we will have x must be greater than 17/60. So negative 7/60 is a little bit smaller than negative 1/10. So it's going to be, oh, and I apologize, these should have all been or equal to. I forgot to have the or equal to from here. So negative 7/60, like I said, is a little smaller than negative 1/10, so it's going to be pretty close to 0, just on the left. And then it goes this direction, and I did the square bracket because it's a less than or equal to. Now 17/60 is a little less than 1/3, so it's going to be a little further along. And then we'll be going here. Okay. All right, and the way that we represent that answer in interval notation would be minus infinity to negative 7/60 square bracket union square bracket, 17/60 to positive infinity. And we're done. Okay. Absolute value inequalities with unusual solution sets. So if if U, and then we've got some missing words in here, is an algebraic expression, and C is a negative number, the inequality absolute U less than C has no solution. Okay? Because if C is negative, it would be saying that positive numbers would be less than that, and that's not true. And the inequality absolute value of U greater than C is true for all real numbers, because you'll get a positive, and a positive number is always greater than a negative. And that is, of course, for which U is defined. All right, so here we go. The inequality absolute T minus 50 is less than or equal to 22 describes the range of monthly average temperature T in degrees Fahrenheit for Albany, New York. Solve the inequality and interpret the solution. Okay, T minus 50, absolute T minus 50 less than or equal to 22 means that negative 22 is less than or equal to T minus 50 is less than or equal to positive 22. When I add 50 to all three parts of the inequality, I get 28 is less than or equal to T is less than or equal to 72. So what does that mean in words? The range of monthly average temperature for Albany, New York is between 28 degrees Fahrenheit and 72 degrees Fahrenheit, inclusive, meaning that those temperatures are included. All right, and we are all done with Chapter 9, believe it or not, since we just have that one section. So don't forget to start working on the assignment set, the problem set for 9.3. Have a fabulous day. Bye.